Okay, so today's lesson we're going to start looking at more properties of exponents. We've already reviewed some of this in previous lessons. We know that if we're raising something to a power, each individual piece, right, gets raised to a power, whether it's a product or a quotient, so whether it's things being multiplied or divided. We also know that there are rules for when we raise something to a power to another power. And all of these rules come back to just the idea of what it means to multiply. So for instance, that first one where we have, something like AB, let's just say to the fourth. Well, that's really AB times AB times AB times AB. But we know that we can multiply in any order. So we can rearrange these things and make it all four A's, all four B's, which of course is A to the fourth, B to the fourth. And that's why that thing matters. With the quotient, it's a lot easier, right? A over B, let's say, cubed is just A over B times A over B times A over B. And we know that we multiply fractions, we just multiply across the top and across the bottom. So that just gives us A cubed over B cubed. So it's pretty easy to see those two rules. Well, this rule is just as easy to see. Because if we say, all right, we got, let's say, B squared cubed. Well, that's B squared times B squared times B squared. All right, three of them. But each of the B squareds is BB, BB, and BB. And look, we've got six of them. B to the sixth, 3 times 2. So that's where those rules come from. They're not something spectacularly, wow-inducing. They're just shortcuts that if we have them memorized, it saves us some time that we don't have to worry about expanding everything out and then contracting it back down to its powers. So of course, we know that with these simple examples, it's just you multiply and you get s to the 8th, just like you get 3 to the 8th. And you multiply each of these, so you get x to the 8th times x to the 20th, which is x to the 28th. Or you could have combined these two and had x to the 7th all to the 4th, which again is x to the 28th. You can see it works in either direction. So, as we've seen, these properties work, whether it's multiplication or quotients. The only thing I have to worry about is, of course, b can't be 0 because you can never divide by 0. We do the same thing with all of these, that if we're raising something to a power, remember that it's this thing being multiplied out 4 times, and then you can rearrange, so each thing is being raised to the power of 4. So this is going to be negative 2 to the 4th, which becomes positive, right, because the negatives cancel whenever it's even. 2, 4, 8, 16. So it's going to give us 16 x to the 4th, y to the 4th, z to the 4th. 5 cubed, right, is 125. Well, squared cubed, you have x squared times x squared gives you 6 of them total. Same thing here, 7 and 7 and 7 gives you 21 of them total. And then the rest of these are easy, right? 2 cubed over 5 cubed. 1 squared is still just 1. 3 squared is 9. This is where students screw up, is they forget to put the power on the numbers, right? And then x squared y to the 8th. Another simple example where we can simplify everything if we just use the rules. So we know that power to power gives us x to the 12th times x cubed. Same thing here, power to power, so x to the 14th. Combine the top. We know when we multiply, we just add. So that's x to the 15th over x to the, 14th. And then when we divide, we know that we subtract, and the answer is x. All that crap just equals x. And then lastly, it still works if we have added stuff in here like multiplication, just like this was technically adding in the step of division. First order of operations means we want to do stuff inside the parentheses, but there's nothing to do inside there, right? There's nothing to combine. So the next thing is we do exponents, which gives us 3cd squared, and then this becomes 2q, which is 8c squared, and then d to the 9th. We don't technically need the parentheses. I just put it there to highlight that this is the new version of that stuff. Now we can do the multiplication of everything together. Let me fix that. That should be c cubed. And now we combine our like terms, 24c to the 4th and d to the 11th. And that's it. Our last example is, now with these types of questions, and these come up a lot in algebra classes, I always tell my students, and this mindset works for a lot of different types of problems. It's always better to simplify something down and make it smaller before you blow it up and make it bigger. Now, if I start squaring things, they're going to get bigger, especially when I start squaring numbers. So if there was, like a 4 up here, it'd be better to reduce and make it, a 1 and a 2 first. Same thing with making all of these powers bigger. Why not do all the reductions that we can first, which kind of goes along with the order of operations. We do things inside the parentheses first. So we have x to the 7th divided by x. That just leaves 6 of them on top, right? We don't have any other y's, so the y doesn't change. We've got 4 z's here and 3 of them down here, so we just have a z on top. We still have the 8 on the bottom. We canceled out the x, we canceled out the z, so there's nothing else down there. And now we can square it. And there's just less work to do. X to the 12th, y squared, z squared, all over 8, which we would probably just write as 1/8 x squared, x to the 12th, y squared, not a z, z squared. For here, I forgot that this should be 8 squared, so we should change that to 64. And then if we want to do it the other way, by bringing the power in first, it's going to be x to the 14th, y squared, z to the 8th, all over 64 x squared, z to the 6th, right? Because 3 times 2, 4 times 2, and 7 times 2. Now we combine like terms. We got the 14 and then 2 of them on the bottom, so 14 minus 2 is x squared. 2 y's, but nothing else, so the y's just stay there. And then 8 of the z's divided by 6, so 8 minus 6 gives us z to the squared, right? And we still have the 64, and you can see that we get the exact same thing at that point. All right, that's everything I've got for you.